Okay, welcome everyone to part 4 of our lesson for image representation. Finally, we will be talking about the first factor which can affect the file size and the quality, of course, of an image, of a bitmap image. And what this means is how many bits are you using to represent each pixel in your image. So bit depth means how many bits are you using to represent each pixel in an image, like so. Now, to show you this as an example, what we're going to do is we're going to very quickly just draw a simple emoji image on this image here. So we'll name this image 1 and this will be image 2. And in image 1, what we're going to do is we're going to use one bit depth. So that means for each pixel we can only use 1 bit, and 1 bit can either be 0 or 1. So if we write 0 and 1 here, that means that we can only use 2 colors, because we can only map 2 colors to 2 binary patterns, right? If we're using 1 bit depth, we can only create 2 patterns, which is 0 and 1. These are patterns. So let's say for 0 we're going to use black, and for 1 we're going to use white. Now this doesn't really matter which colors we use. It could be that black is 1 and white is 0. It could be that we're using red and green. It could be that we're using blue and purple. It doesn't matter what the colors are. What matters is that we're only capable of using 2 colors because we are restricted to only 2 patterns. We cannot create any more patterns out of 1 bit. It can only be either 0 or a 1. So using this as our base for our image, so 1 bit depth, we can create something like this, like so. And then we'll draw the eyes, and let's draw the mouth here as well. Now I cannot add any more color to this. I can add, I can change the colors. So if I want to make, for example, this pixel over here black, this pixel over here black, and so on and so forth, I can do this. I can mess around with the different colors of the individual pixels, but I cannot actually add any other colors. For this image, they just do not exist. They are not capable of being represented. If I change at some point what, for example, the pattern 1 is representing, like for example, we can change it to red, then that will immediately change all of the pixels in the image that are white to red as well, because it is incapable of now representing white. Now in image 2, what we're going to do is we're going to increase the bit depth, and we're going to use 2 bit depth. So that means we're going to be using 2 bits to represent each individual color. But the benefit behind it is that now we can create more patterns. So we can create 0, 1, 1, 0, and 1, 1. So we can use a total of 4 colors, like so. So let's say black, white, yellow, and blue, like so. Now let's draw the same emoji, the same picture on the other side, on the same cells as the previous one. Like so. Now immediately you can see that by increasing the bit depth of an image, we are able to represent more colors, and that in turn increases the quality of the image. So increasing the bit depth increases the quality that we are able to represent. But unfortunately, it does also increase the file size. The reason behind this is that if I wanted to save image 1 in my computer, then I only have to save, for example, let's just use the first row as an example. For red, I would have to use 1 1, or I would have to save 1 1 0 0 0 0 1 1. And if I save this data on my hard drive, I am only required to use 8 magnets on my hard drive. So for example, this would be north, north, south, 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 north, and then north one more time there at the end. So using 1 bit uses less space on your hard drive. Looking at image 2, to save image the row that is on the top, row 1, I would have to save 2 bits. So then that means I would have to use 2 magnets on my hard disk drive just to save a single pixel. Whereas for image 1, I was only using 1 magnet to save 1 pixel. So you can clearly see here that by increasing the bit depth of an image, you are directly increasing the file size of an image, but of course the quality will be increased as well. And I can show you an example of this. This is an image I found online. It was taken from Wikipedia. We'll just increase the size here. Now, if you look at the column here, or the part of an image, or part of the image on the left-hand side, you can see that they're using 1-bit color, and this is what the image will look like if you can only use black and white. So you cannot represent any other color other than black or white. But you can see here that the file size, 42 kilobytes, is a much more smaller file size than the one on the far right, which is using 24 bits, and the file size is 1.2 megabytes. So the file size has increased with the color depth, but of course the quality of the image has increased as well. This one here, the second column, is using 8-bit, but it is in black and white, so that means we're only using black, white, and everything in between that, which is all the grays. The quality of the images is pretty good because we can represent 256 different grays. That's a quite wide range. It is sufficient to show the image, and the file size is good. Now looking at the third column here, we can see that the file size is the same as the black and white picture, even though we're using color. The reason why it's the same size as the second column is because we're still using 8 bits. Unfortunately, the quality of the image isn't as good as the black and white one, because now we are restricted to the amount of colors we can use. And of course, the last column, which is the 24-bit color depth, we are able to use 16 million different colors, which is a very, very adequate amount. And if you guys are wondering what 32-bit color depth would mean, the final 8 bits, because the difference between 24 and 32 is 8, so we have an extra 8 bits here with 32-bit color depth. This 8 bits is used for transparency. So I'm sure if you have ever used an image editing program in your life, you have messed around with the opacity of a layer or of an image. By decreasing the opacity of that pixel, you are reducing the value of these final 8 bits in the color depth. By increasing the opacity to 100%, then you are increasing the value of these 8 bits to FF, which is 255, and so on.